Today we're going to talk about linear equations and how to go about solving them. A linear equation is an equation that can be written in the form of ax plus b equals 0. Now, in the past, when we've talked about linear equations, we've talked about graphing, and we would write them in the form of y equals mx plus b. And as you can see, this is very similar. Well, if you remember, there are several names for finding the solutions. We can talk about finding the solutions or solving for x. We can talk about finding the roots, which again is simply solving for x. Or we can talk about finding the zeros. When we talk about finding the zeros, well, then we're talking about where the graph of the equation would cross the x-axis, or we can look at it as where the value for y is simply 0 because we're on the x-axis. So what we're doing is we're taking a linear equation that would graph to be a line, and we're finding the point where it crosses the x-axis. And so we're finding the 0 of it, therefore we set the equation equal to 0. Now, what we're doing when we go about solving for our linear equations is we simply set up a series of equivalent equations. What we mean by equivalent equations are equations that look different but have the same value or the same solution, the same 0. So we could have the equation 5x plus 3 equals 13. Now, if we went through and we substituted in 2 for x, then we would find that this was a true statement, and therefore 2 is a solution for this equation. And we have then 13 equals 13. We made a true statement. So x equals 2 would be a solution for this equation. And you make that a equals. Would be a solution. Now, we could also have taken the equation 5x equals 10. And again, if we substituted in 2 for x, then we would have a true statement. 10 equals 10. So x equals 2, again, is a solution, or it satisfies this equation. So these are two equations that are equivalent. They don't look the same, but they have the same solution or the same 0 or the same root. And we could write the answer in a solution set form of x equals 2. So we say that these two equations are equivalent. And what we do then when we start solving our equations is we turn them into a series of equivalent equations. So let's start with this equation. 4 times 2x plus 1 is equal to 29 plus 3 times 2x minus 5. Okay, we've got several steps that we're going to go through, and they're very similar every time as you begin solving your equations. Now, the first thing that we're needing to do as we go through and solve this is to get rid of our parentheses. We cannot begin to simplify this or to solve it until we have simplified it first. So if we were going to put down a step for this, we need to remove our parentheses. We do that by using our distributive property. So we're going to distribute the 4 and have 8x plus 4 equals 29. And then we're going to distribute the 3 to remove that set of parentheses. So plus 6x minus 30 minus 15. Thank you. Okay, so what we've done is we've removed our parentheses. Now over here we have some like terms that we can combine and to make that just a little bit simpler. So we've got 8x plus 4 is equal to 29 minus 15 is 14 plus 6x. So as we begin solving our equation, the first step that we need to go through is to simplify it by removing the parentheses and combining like terms. Now, if you remember, like terms are terms that have the same variables to the same power. And so we can go through and uh, combine those. It could also be that we would just be combining numbers like we did on that step. So we begin by simplify by removing the parentheses and combining like terms. Now, as we go back to this, then, we're ready to uh, begin solving. And at this stage, this is the most complicated equation that we will ever solve. If it's more complicated than this, then that means that you could have done some simplifying by removing parentheses, combining like terms, and doing some other things. Okay, we're solving for our variables, so we like to get our variables on the same side. We're going to do that by adding or subtracting. Basically, what we're trying to do is to get 0 with the 14. We're trying to make this part 0, and we do that by adding the opposite. That's called the additive inverse property. So since it's a positive 6x, we're going to subtract 6x. And if we do that to one side, we have to do it to the other side. That's our subtraction property of equality. So what we're left with is 2x plus 4 equals 14. So our second step then in solving our equations, after we remove the parentheses and combine like terms, then we want to move all variable terms to one side of the equation. It doesn't matter which side you move it to, but you move it to one side, and you do that by addition or subtraction. And now we want to solve for our variable, so we want to get our variable term alone. That means that we need to make this plus 4 right here, we need to make that 0. So we again use our additive inverse property. We're going to subtract 4. But if we subtract 4 from one side, we have to subtract 4 from the other side. So what we're left with is 2x equals 10. So we went through and we got our variable term alone by addition or subtraction. So we got our variable terms on one side, then we got our variable term alone. Now we want to solve for our variable. And we can do that by one of two ways. We can either multiply by the reciprocal of the coefficient, which in this case would be 1/2. So we can multiply both sides by 1/2. Or when our coefficient is an integer, it's easier if we will simply divide it by that coefficient, because what we're wanting to do is to get a coefficient of 1. So we're using our multiplicative inverse property so that we can get a coefficient of 1. And we then get x equals 5. So we can solve for the variable by multiplication or division. Now, if you notice, what we've done is we've started solving these is we've pretty well done our order of operations backwards. Our order of operations were we did powers, we did multiplication or division, and then we did addition or subtraction. Now, if we wanted to do anything out of order, if we wanted to do some addition and subtraction before multiplication, we had parentheses, and that was to simplify it. So what we've done here is we've simplified by using removing the parentheses and combining like terms. Then we started by undoing our addition or subtraction. And so we started by undoing addition or subtraction. Then we undid our multiplication or division. If we had had exponents, then that would have been the last thing that we would have undone uh, and taken care of our powers. So we solve our linear equations by undoing our order of operations. And as long as you remember that, then it makes it a little bit easier to figure out what to do next. Now, of course, the last step should be to always check your answers and to see if those are correct. And you check your answers by taking that value that you got for your answer and substituting it back into the original equation. So we got x equals 5. So if we go through and we substitute that in, we're going to have 4 times 2 times 5 plus 1 equals 29 plus 3 times 2 times 5 minus 5. And if we work this out doing what's in our parentheses first, we're going to have 10 plus 1, which is 11, is equal to 29 plus 3 times 10 minus 5, which would be 5. So we have 44 is equal to 29 plus 15, or 44 equals 44. So it checks out. So we can keep going through our steps for solving equations, and those are the steps that we'll use on every one. And again, they don't get real complicated as long as you've taken care of step 1 of simplifying by removing the parentheses. And let's look at one more and go through it. So let's take the equation 5x minus parentheses 2x, excuse me, okay, 2x plus 2 is equal to x plus 3x minus 5. And that's not the neatest I've ever written something. 5x minus 2x plus 2 is equal to x plus 3x minus 5. Now we need to start by removing our parentheses. So as we do that, we have 5x. We remove our parentheses by using the distributive property. In this case, we're distributing a negative 1. When no number's there, it's understood to be a 1, and in this case, the sign was a negative. So that's going to give us negative 2x, then negative 1 times positive 2 is negative 2. It's equal to x. Now again, in front of this one is a 1, but it's a positive 1. So positive 1 times 3x is 3x. Positive 1 times negative 5 is negative 5. So remove the parentheses. Then we need to combine like terms. Well, we have 5x minus 2x would be 3x minus 2. On this side, we have x plus 3x is 4x minus 5. Okay, we want to get our variables on the same side. So we're either going to need to subtract 3x or subtract 4x. It doesn't matter which one you do. So I'm going to go ahead and subtract 3x from both sides. So we're left here with negative 2 equals x minus 5. Then we want to get our variable alone, so we're going to add 5 to both sides, which gives us 3 equals x. Now, if you don't like it written that way, we can use the symmetric property and switch it around. And so those are the steps that we go through as we begin to solve. Okay, the next set of problems that we're going to look at is where we solve and there's going to be a constant in the denominator. And another way of putting this is we're going to have fractions. So if we look at begin with this one of x minus 3 over 4 is equal to 5 over 14 minus x plus 5 over 7. Now, when you have fractions and you're combining fractions, if you remember, what you do is you get a common denominator and then you only add the numerators. And the denominator doesn't change. Well, we're not trying to add these, we're trying to solve for x. So we want to make some equivalent equations. And the way that we do this is we're going to go through and we're going to multiply both sides of our equation by our common denominator. What will do is it's going to make that equivalent equation. Let me just give you a quick example off to the side. Let's say that we've got x over 3 plus 2 over 5, and we're wanting equals 5/15, which could have been simplified, but we're going to leave it 5/15 so that we see real quickly what we do. Now, what we would have to do here is to get a common denominator. Well, that common denominator is 15. So if we changed our 3 to 15, then what we're going to have to do is to multiply it by 5. And to keep it equivalent, we would have to multiply our numerator by 5 also. Here, if we want a denominator of 15, we're going to have to multiply our denominator by 3. So we would have to multiply our numerator by 3 also. And that's going to equal our 5/15. So what we have is 5x over 15 plus 6 over 15 equals 5 over 15. Now, we're wanting to figure out what x is. Well, our denominators don't have anything to do with that because they're all the same. All you do is you combine the numerator. So we're going to have the equation 5x plus 6 equals 5. Well, that means we would subtract 6 and then divide by 5. So x equals negative 1/5. And right now, it doesn't matter that that's a fraction or that it's negative. We've simply come up with that value then for x. Now, if you notice right here as we began working with this, if I'd taken this same equation, the 5x plus 6 equals 5x over, excuse me, let me take it, the original equation, which was x over 3 plus 2 over 5 equals 5/15. And I had multiplied everything by 15. Well, if I multiply this term by 15, then notice 3 is going to go into 15 5 times, and I have 5 times x. Well, that's the same thing that I did here. I ended up with the 5x because I figured up what I needed to multiply my numerator by, and I had to multiply my numerator by the same thing. So I end up with 5x. And in the second term, if I multiply by 15, well, 5 goes into 15 3 times, so 3 times 2 is 6, which is the same thing that I ended up doing up here, was multiplying 2 times 3 and getting the 6, because that's what I would have needed to have multiplied my numerator by in order to make it my common denominator. And then on the last one, if I multiply by 15, my 15's cancel and I end up with 5. So I've ended up with the same equation that I had to use to solve. And I did it a little bit easier way than getting my common denominators. So the method we want to use to solve when we have denominators is to multiply both of the equations, both sides of the equations, by the common denominator. Now in this case, our common denominator would be 28. And if you've forgotten how to get common denominators, you can do it by prime factoring. The prime factors for 4 is 2 times 2. For 14 is 2 times 7. Now we line that 2 up under one of the other 2's we've already written. So we have 2 times 7, and then the last one, the only factor, is 7, the prime factors. Then what we do is we simply think of the columns that we have lined up and we multiply those together. So we have 2 times 2 is 4 times 7 is 28. And so 28 is our common denominator. So we're going to multiply each term by that common denominator. And we're actually multiplying both sides of the equation, which is using our multiplication property of equality, but we went ahead and distributed it to both those terms. So here we have 4 goes into 28 7 times. So we're going to have 7 times 8 minus 3 is equal to 14 goes into 28 2 times. So we have 2 times 5 minus 7 goes into 28 4 times, and we have 4 times x plus 5. Now it's important to remember that those numerators are understood to be in parentheses. So now we distribute. We have 7x minus 21 equals 10 minus 4x minus 20. Don't forget we're distributing a negative 4. Combining our like terms, we have 10 minus 20 is negative 10 minus 4x. And again, this is as hard as you'll ever have to solve. So we're going to add 4x to both sides. That's going to give us 11x minus 21 is equal to negative 10. Then we will add 21 to both sides. And we have 11x is equal to 11. Dividing both sides by 11, we get x equals 1. Okay, let's look at one more that's along that same line. And let's look at 5 plus x minus 2 over 3 is equal to x plus 3 over 8. Okay, in this case, our common denominator would be 24 because the 5 is understood to be over a 1. Now, we still have to multiply the 5, even though it had a denominator of 1, we're needing to multiply by that common denominator. So we're going to multiply each term by 24. And I'm going to go ahead and put that numerator in parentheses just to remind myself that they're understood to be in parentheses. That's part of our order of operation. So 24 times 5 is 120. Then we can cancel. 3 goes into 24 8 times, so we're going to have 8 times x minus 2 is equal to 8 goes into 24 3 times, and we're going to have 3 times x plus 3. We have 120 plus 8x minus 16 is equal to 3x plus 9. 120 minus 16 would be 104 plus 8x is equal to 3x plus 9. We want to get our variable terms on the same side, so we're going to subtract 3x. We have 104 in plus 5x is equal to 9. Then we're going to subtract 104. And we have 5x is equal to negative 95. Dividing both sides by 5, we have x equals negative 19. And I haven't been substituting in to check, but to check these, you would simply substitute them into the original equation. Now, we want to look at then solving our equations with variables in the denominator. And the thing that we're going to have to look at before we can solve an equation that has a variable in the denominator is that we limit our domain. Now, in our set of real numbers, there's only two things that we cannot do mathematically. One of them is to divide by 0. The other one is to take a square root of a negative number. Now, taking the square root of a negative number, if we move on to our set of complex numbers and that include our imaginary numbers, we can take the square root of a negative number. But in the set of real numbers, which is what we're working with right now, and if you move on into calculus and other subjects, all you will work with are your real numbers. In our set of real numbers, we can't take the square root of a negative, and we cannot divide by 0. Now, we can't divide by 0 in any set of numbers. So that's something that's always impossible to do. Those are the only two things that will limit your domain in the set of real numbers. And there will be some things that we'll work with later when we're dealing with our graphs that we'll talk about limiting the domain. And those are the two things that we will look for. So as we begin working our problems, then what we're wanting to make sure of is that when we get our solution, it's not going to give us 0 in the denominator or a negative number under the radical. So we'll work with this first equation, x minus 3 over 4. Excuse me, we're already done that one. We're going to have 5 over 2x Sorry, it's not wanting to write. I'll just change colors then. 5 over 2x is equal to 17/18 minus 1 over 3x. Now, what we're going to do here is we'll look to see what would make any of our denominators 0. Well, in this first one, the 2x, the only thing that would make that 0 is if x equaled 0. Or one way that you can go about doing it is you can take that denominator, 2x, set it equal to 0, and then solve. So if x equaled 0, then that denominator would be 0. So therefore, x cannot be 0. Because if we did and we plugged it back in, it would make the 2x, it would make the first denominator a 0. It would also make this denominator 0. So when we get our answer, it cannot be 0. We know that to begin with. Now we're going to multiply all of our terms by our common denominator. We get the common denominator the same way that we have in the past. For 2 and for 3, our common denominator is 6. Then for our variable, you take every variable the most that it appears in any one denominator. So that would be x. It appears once in each one of these. So that would be 6x. And again, you could do that by your prime factoring we could have factored, we have the factor of 2, we have the factor of 3, we have the factor of x. And, uh, and we could have actually put that as the 2x. We had a factor of 2 in x and a factor of 3 in x. So when we multiplied all of these together, then we get 6x for our denominator. So we're going to multiply all of our terms by 6x. So we have 6x times 5 over 2x is equal to 6x times 17 over 18 minus 6x times 1 over 3x. Okay, we can cancel. The 2 goes into the 6 3 times. The x's cancel. So we end up with 15 is equal to, well, 6 goes into 6 once. I've really made a mistake here, haven't I? I left out that 18 altogether. So I'm sorry, we're going to go back and we're going to change this. And I do make mistakes, so let me just change this because 6 is not our common denominator. I bet y'all were sitting there saying, well, what about the 18? So we have a factor of 18, and that's going to change our common denominator. And a lot of times you will make mistakes, and there's ways of catching them as you go ahead. So if we did the 18 is 3 times 2 times 3. So when we put these together and do our multiplication, we have a 3 times a 2 times a 3 times x, which will give us, let me just mark that out, 18x. So let's go back now. I'm sorry on that. We have 18 times 5 over 2x. 18 times 17 eighteenths minus 18 times 1 over 3x. And I kind of figured that out when I was still going to have a denominator left. So the 2 goes into the 18 9 times. 18x. I'm going to get this one right. And the x goes into x one time. So we have our 9 times 5 is 45. Is equal to our 18's cancel. And we have x times 17, or 17x. Then minus our 3 goes into 18 6 times, and our x's cancel, and so we have 6. Now, we simply want to get our variable term alone, so we're going to add 6 to both sides. We get 51 equals 17x dividing both sides by 17, we get x equals 3. Okay, so let's do another one like similar to that, since I made so many mistakes on that one, and see if we can do just a little better job. Okay, let's take this one. And we have x over x minus 2 equals 2 over x minus 2 minus 2 over 3. Now in this case, these denominators, the x minus 2, remember they're understood to be in parentheses, so they're just like a single number. So we have x minus 2, our second one, we have x minus 2, and then we have a factor of 3. So our common denominator is going to be 3 times x minus 2. And we're going to multiply each term by that. Now, as we're doing that, let's stop and think, what would make our denominator 0? How do we go about limiting our domain on this one so that we know that our denominator cannot equal 0? Well, we know the 3 can't be 0, so it doesn't come into play. But that x minus 3, or x minus 2, if x minus 2 cannot equal 0, then that means x cannot equal 2. So if we end up with a 2 for an answer, then we're not going to be able to use it. Okay, right here, remember these are understood to be in parentheses, so they're going to cancel. And we'll have 3 times x, or 3x, is equal to, the x minus 2's cancel. We have 3 times 2 is 6. Then our 3's cancel. And right here, we've got a negative 2 times x minus 2. So that's going to be negative 2x plus 4. That negative 2 times the negative 2 would give us a positive 4. And if you need to write that down, you've got the minus, and then go ahead and put 2 times x minus 2. Write that down so that you can keep your sign straight. Okay, our like terms, we've got 10 minus 2x. Then we need to add 2x to both sides. So we have 5x equals 10. And then dividing both sides by 5, x equals 2. So we got a nice answer for our equivalent equation, but we've already said that it cannot be 2 because that would make our original equation 0. So what we have to do here is, since that can't be 2, then we simply say there's no solution. So that's one of our reasons then for limiting our domain. All right, we've got one more that I want to look at that's in this same type of section. And so let's go ahead and look at it. If we have 2, if we have 2 over x plus 1 minus 1 over x minus 1 is equal to 2x over x squared minus 1. Now, in the first two, the 2 over x plus 1 and 1 over x minus 1, those denominators, they're understood to be in parentheses, and we would treat those as one terms. But in this last one, we have x squared minus 1. And that's not in simplest factored form. So x squared minus 1, that's the difference of squares. And if you remember, that factors to be x minus 1 times x plus 1. It's in the form of x squared minus y squared, which factors to be x minus y, x plus y. And we'll talk a little bit more about factoring later. Any factoring you're going to do right now will be fairly simple, and the difference of squares is something that you should remember from your earlier algebras. So this one would factor, and let me just go ahead and put it this way. This factors to be x minus 1, we'll make that x plus 1, times x minus 1. So our common denominator then is going to be x minus 1, x plus 1. So what we're going to do is we're going to go through and we're going to multiply each term by x minus 1, x plus 1, times 2 over x plus 1, minus x minus 1, x plus 1, over, times 1 over x minus 1, equals x minus 1 times x plus 1 times 2x over x plus 1, x minus 1. Now, we didn't limit our domain. So what would it that would make our denominator 0? Well, again, if we took the x plus 1 right here and set it equal to 0, it would be x equals negative 1. So x cannot be negative 1. Or if we took the x minus 1, set it equal to 0, we're going to get x equals 1. So x cannot be equal to 1. We don't have to worry about these two because they're going to give us the same answers. So we can cancel our x plus 1's, and we're going to end up with 2 times x minus 1 minus, we can cancel our x minus 1's, and we'll have negative 1 times x plus 1 is equal to, and in this case they both cancel, which is 2x. So we have 2x minus 2 minus x minus 1 equals 2x. And that gives us x minus 3 equals 2x. Subtracting x from both sides, we get negative 3 equals x. And that didn't violate our original problem. Okay, we're going to stop here on this one and then pick up with section 1 in the next lesson.